Today we're going to look at Newton's second law and how it applies without friction. Now just a quick review, Newton's second law tells us the net force, or the sum of all the forces, is going to equal ma. Alright, so the example we're going to look at is we have a 15 kilogram block on a frictionless surface. We'll look at friction in another video. And there's going to be a 24 Newton force applied at an angle of 20 degrees above the horizontal. We're going to pull on that block and we want to figure out what's the acceleration of the block and what's the normal force acting on a block. What's the source or the force from the surface below it? All right, so how do we set up one of these problems? Well, the first thing we need to do is draw a free body diagram. So what are all the forces acting on my object? Well, easy one, gravity. So the force of gravity acts straight down. mg is our force of gravity. We have our 24 Newton force. Is there friction? Nope. Is it on a surface? Yes, so there is a normal force. And remember, our definition of normal is normal means perpendicular to the surface. So therefore, our normal force always points perpendicular to our surface. So we have these three forces. But what we're going to want to do is we're going to want to think about this in an x, y frame. Meaning, we are going to want to resolve any vectors that are not solely in the x or solely in the y into components that are in the x or the y. So our 24 newtons needs to be resolved. So we're going to go ahead and we're going to resolve it into the components. So this component down here is 24 cosine of 20, and this one here is 24 sine of 20. Now, some people like to redraw this free body diagram just to organize it a little bit. So all the blue arrows, I'm going to redraw it with just those. So I have the normal force. I have the 24 sine of 20. I have 24 cosine of 20 and mg. The reason we like to redraw it is you can see, hey, which vectors are in my y direction, which vectors are in my x direction. All right, let's think about Newton's second law, because there's also a first law in here as well. So when I think about this, this is a two-dimensional equation. We got to think about these as vectors. So what that means is I'm going to resolve this equation just the same as I resolved this vector into an x and a y. I'm going to do the same thing here. So I'm going to talk about summing up the forces in the x direction, and I'm going to talk about summing up the forces in the y direction. And I have to decide, is it accelerating in the x or is it accelerating in the y? Now ideally, and we're going to see this with inclined planes, we want to isolate the acceleration to either the x or the y. We don't want to have it have components if we can. So in the x direction it is accelerating, so all of the acceleration is in the x direction. In the y direction, it is not accelerating. And what this means for me is my x component of my acceleration is my total acceleration. If I have it as some sort of mixture, I'm going to have an ax and an ay, and then I'm going to have to put those components back together. We want to try and not do that. All right, so once we've identified its first law in the y direction, second law in the x direction, we're going to go ahead and create our equations. We're going to use our free body diagram to generate equations off of these Newton's first and second laws. So in the x direction, all the forces acting in my x direction, I have 24 cosine of 20 equals ma. All right, so if I want to find the acceleration, I just have to divide by the mass. They gave me 15 kilograms. Kilograms is a mass. All right, so here we go. We're going to divide that over, so now I have 24 cosine of 20 divided by my mass, which was 15, will give me an acceleration. In this case, when I plug this in my calculator, I end up with 1.5 meters per second squared. So we found the acceleration. Now I want to find the normal force. Now this is one that we get confused on sometimes, because here I have a force at an angle. If you don't have a force at an angle, that normal force might be equal to mg. Okay? Or if you're just standing here, normal force is equal to mg. Don't get in the habit of just saying normal force is the weight of the object. It's not always going to be that way. Sometimes it doesn't have to support the whole weight because something's helping it. All right, so let's go ahead and figure out what that normal force is. That's going to be pretty important for us when we get to friction. So in the y direction is where we will solve this. So what we'll do is we'll generate this equation. So I'm going to sum up the forces in my y direction here. So I have normal force plus 24 sine 20, and then plus a negative mg. The reason it's negative is because it's pointing down. Again, remember, we're adding vectors together, so it's pointing down, and this will all add up to 0. So then n is just going to equal mg minus 24 sine 20. And you can think about the normal force has to support the weight minus the help it's getting from the angled force. Plug this into your calculator. You should get a normal force of 139 newtons. And again, this is going to be important for us when we get to friction. Let's do that next.